move into chapter 2, the third section, we're going to be simplifying variable expressions. This first expression, can anyone know or tell me how to make it in a simpler form? You can't solve it, but how can you simplify this expression? So we're going to discuss today, we have somebody saying that you can say 7 minus 5, and that's going to be 2. But the 3x and the 4x, we're not sure what to do with them. So let's move on to this lesson so we can learn how to simplify these kind of expressions. The parts of an expression that are added together are called terms. In the expression below, the terms 5x, 4x, and 7 are called terms. The coefficient of a term with a variable is the number part of the term. The coefficient of a term with a variable is the number part of the term. So example, in 5x, the 5 is the coefficient. In 4x, the 4 is the coefficient. A constant term, such as 7, has a number but no variable. Like terms are terms that have identical variable parts. In the expression above, 5x and 4x are like terms. So now we're going to talk about how to identify parts of an expression. Identify the terms, like terms, coefficient, and constant terms of the expression y plus 8 minus 5y minus 3. Now when you have that expression, if you would like, you can change that to an addition. So you can write the expression as a sum. You can see here where y plus 8 plus negative 5y plus negative 3. Now we're going to identify the parts of the expression. Note that because y is equal to 1y, the coefficient of y is 1. So in this example, in this expression right here, how many terms are there? 1, 2, 3, 4. There are 4 terms in this expression. So our first term is going to be a y. Our next term is going to be an 8. Our next term is negative 5y. And our final term in this expression is negative 3. Our like terms in this expression. Who can tell me what the like terms in this expression are? Yes. Okay, so we have made notes of the like terms, our coefficient in these two terms. So now you've noticed that our coefficients are 1 and negative 5 because there's an understood 1 in front of the y. Negative 5 is the other coefficient. Constant terms are 8 and negative 3. Now, when you're simplifying expressions, you can use the distributive property to write an expression such as 7x plus 4x as a single term. So you have 7x plus 4x. What do the 7x and the 4x have in common? Yes?
They both have x.
They both have an x in it. So we can write it 7 plus 4 in parentheses, putting the x on the outside, and each of these equal 11x. So now we can simplify an expression in example 2. And we can do like we did in the previous example, change this to a sum. So if you would like, you can change this to a sum. 4n plus negative 7 plus negative n plus 9. Now we have been asked to simplify this expression. So you can take 4n plus negative n plus negative 7 plus 9. 4n plus negative n is 3n. If you have 4 n's and you take 1 away, because you know there's an understood 1 in front of here, 4 minus 1n, 4n minus 1n is 3n, plus, if I wanted to combine my constants, negative 7 plus 9 is what? 2. So in order to, when you simplify this expression, would be 3n plus 2. So in these next 3 examples, we're going to identify the terms, the coefficients, and the constant terms. You're asked just to simplify it. I need you to add like terms to number 1 and 2. Okay, so in example 1, our terms are 3x, 2, and 5x. The coefficients are 3 and 5. The constant term is 2. The like terms are 3x and 5x. Number 2, our terms are negative 7b, 3, b, and negative 10. The coefficients are negative 7 and 1. The constant terms are 3 and negative 10. The like terms are negative 7b and b, and then 3 and negative 10. So in our third example, our terms are 5, 8w, negative 6, and negative w. Our like terms are 8w and negative w, and negative 6 and 5. Coefficients are 8, negative 1. Our constant terms are 5 and negative 6. Now, a quick way to combine like terms containing variables is to add their coefficients mentally. Now, you had this example in the previous screen. 4n plus negative n, it's just like saying 4 plus negative 1, and that is 3. So 3n would be your solution for that. So now we're going to simplify expressions with parentheses. In example 3a, we're going to use the distributive property. Which number is going to be distributed inside the parentheses, Jack? 2. So we're going to simplify this expression. So 2 is going to be distributed inside the parentheses. 2 times x is 2x. 2 times negative 4 is negative 8. And I'll bring the rest down. Now I'm going to simplify. Let's do B. Again, you're going to be distributing. What number is going to be distributed to the inside of the equation? Andrew? 8. Negative 8. The sign of the number is what's in front of it. Okay, so we're going to do 3k. Then we're going to be distributing, you can do it this way, 8 to each of the numbers inside the parentheses. So that's going to be, I brought my subtraction sign down, you've got 8k. But here, it's not a positive 8 times 2, it's a negative 8 times a positive 2, which is going to be negative 16. So now you're going to combine 3k minus 8k. If this helps you, you can do this. Add the opposite. Otherwise, you can do it in your head. It's negative 5k minus 16. You don't have to do that second step if you can notice and simplify it from that. But if you need to change it to a sum right now to help you, you can. In our last problem on this page, we're going to simplify this problem. Now we have 4a minus parentheses 4a minus 3. Now we're asked to simplify it. Now, how are you going to simplify this problem? As we have spoken before, there's an understood 1 in front of this. There's one of those. So we are going to distribute -1 to everything inside the parentheses. So -1 times 4a is -4a. -1 times a -3 is a +3. If we're asked to simplify it, 4a minus 4a is going to be 0, plus 3. 0 plus 3 is 3. Now the question has been asked before, how do you know when to put a 1 in front of the parentheses? Well, if you're asked to simplify a problem, and we're going to continue to do more examples of this so that you'll know when to put a 1 in front of the parentheses to distribute it. Now we're going to do 3 examples of simplifying. Again, we're just simplifying these expressions. So we're going to use the distributive property in number 4. 4 is going to be distributed to everything inside the parentheses. Using the commutative property, after you've tried to work out as far as you can for number 4, check your answer. I'll do each one and then we'll go back and review. Here again, you're asked to simplify, so you need to write a -1, you need to write a 1 in front of the parentheses in order to simplify. Then you're going to distribute -1 to everything in the parentheses. So -1 times c is -c. -1 times a +2 is going to be a -2. Then if you have 8c minus c plus 2 minus 2, you now have 7c because the 2's cancel each other out. 8c minus c is 7c. In our final example, example 4, writing and simplifying an expression. You work out each day by jogging around a track and swimming laps in a pool. You spend a total of 45 minutes jogging and swimming. You burn 14 calories per minute when jogging, 8 calories per minute when swimming. So you know in this equation, how long are you working out for? 45 minutes. How many calories do you burn when you jog?
14.
How many calories do you burn when you swim?
8.
So that's the information that we know. In A, let J be the time you jog in minutes. Write an expression in terms of J for the total calories you burn during your workout. And then on B, you're to find the total amount of calories burned if you jog for 20 minutes. So I went ahead and in your notes, if you can't see, if it's too small, write it out below it. We're going to take the calories per minute jogging. So how many calories do you burn per minute when you jog? 14, so that's going to be 14J. Plus, how many calories do you burn when you swim? 8. So I'm going to take A and take the 45 minutes and subtract however much time I'm jogging. Because you're jogging and swimming in those 45 minutes. And that's going to equal something. So 14 calories for jogging, 8 calories for swimming. That is our A part. B, they want to find the total number of calories burned if you jog 20 minutes. Where am I going to substitute the 20 in this expression? Yes?
Where the red J is.
Where the J is. But before we do this, let's simplify A using the distributive property first, and then just simplifying it. You cannot solve it, but let's simplify. So I'm going to have 14J plus 8 times 45 is 360. Minus 8J. Now I'm going to simplify it because you've got 14J minus 8J plus 360. 14J minus 8J is going to be 6J plus 360. So we took our formula and simplified it. Now we're going to substitute in part A when J is 20. So 6 times 20 plus 360. 6 times 20 is 120 plus 360. So you burn a total of 480 calories when you work out for 20 minutes. My objective today is to help you to simplify expressions, combining like terms, not solving them, but simplifying them.